All right, yeah. So my name's Tim Delaney. I'm from Creeklands Conservation, and in collaboration with SBCAN, we are working on a community level water quality monitoring program in the Santa Maria River watershed. We originally had our sights set on the Santa Maria estuary, but events out of our control have slowed that down. There's construction going on down there. So we're going to do a little bit of a pivot to river monitoring in the interim until public access is restored to that estuary. So I'll talk about all that in a few minutes. I just wanted to show you our mission. It's to conserve and restore watersheds and the connected nearshore marine ecosystems throughout California's Central Coast through conservation science, education, and stewardship action. And then some background here, a little bit of history. We've been around since 1983. We were called Central Coast Salmon Enhancement back then. We changed our name in 2019 to kind of account for the different direction we've taken since we were founded. But when it was founded, salmon were raised out in Avila Bay. That was until 2007, and so those would get released. And so it was kind of a local fisheries program, nonprofit with a big community underneath it. Today we focus a lot on habitat restoration, education, specifically like at grade school levels, but also for adults and families as well. Citizen science programs, for example, what we're doing here in Santa Maria. And our ultimate goal is to delist South Central California coast steelhead as a protected species. They are listed because they are threatened. So it's going to take a lot of work to bring them back. And we consist of volunteers, scientists on staff, and several area partners to lead regional conservation efforts. And so specifically, what we're working on here is a project called the Santa Maria River Healthy Watershed Initiative. And it consists of a lot of players and partners and grants at this point. But for this instance, we're funded by Cal EPA and Rose Foundation. And like I said, we're working with SBCAN under these grants. So the 3 bullet points here, we're looking at environmental justice in terms of providing access to programs for underserved populations, STEM education through a watershed lens specifically, and stakeholder development through outreach and education. And so that's kind of a little bit of what we're doing today. And there are some tasks under that, and we're focusing on water quality monitoring right now, but there's some other things on the horizon, a watershed report card, some more education and outreach content that our education team is working really hard on, and as always, more stakeholder development. So for the volunteer component of this, just some things to highlight. I think this is a good way for people to see their watershed from a new perspective. You probably haven't seen your watershed close and personal with scientific devices and monitoring. So it really, it can reshape the way you see the ground. There will also be demonstrations of how to use water quality equipment, and that can be valuable. You'll also be able to collaborate with members of your community. And this is also a way to get started as an advocate for the environment in your region. And hopefully you'll see that by the end of this. Excuse me. So the agenda here is broken up into 3 parts. We've got the Santa Maria River and the estuary, just going to give an intro to that. Some of the science of water quality that as it pertains to this volunteer effort, and how you can measure water quality. So here's a kind of an old picture of the Santa Maria River right at the estuary. It's flowing at a trickle in this picture, but it still pretty much looks like that today. This is just an overview of what the Santa Maria River watershed consists of. And some of it's cut off. Actually, I had to cut it off because it's a really big watershed. It's one of the biggest ones we have in the Central Coast. And I just want to review a little bit of what a watershed is here. Everything inside these black lines, that includes the green and orange, is the Santa Maria River watershed. So anytime a drop of water falls within these black lines, it will ultimately be fated for the Santa Maria River and the ocean. In between where it falls and the ocean, people may pick it up and use it to irrigate something, and they drink it, but it'll eventually make its way out to the ocean over time. And it's broken up into these two shapes because the Cuyama River kind of deserves its own name because of how big it is. But we also have, not labeled here, the Sisquoc River in the upper portion of this green watershed. And so the Cuyama and Sisquoc meet and create the Santa Maria River. You can see that in that darker blue. I also marked here the Twitchell Reservoir, which we'll talk about a little more. And just to orient you, here's the city of Santa Maria, there's Guadalupe. These are the two communities that are most affected by the Santa Maria River. And so, yeah, all of that water is going to flow out to the ocean, but before it gets there, it's going to stop in the estuary for a little bit, and some interesting things happen in estuaries. Just a little review of the Santa Maria River channel. So kind of focusing in on that dark blue line in this picture. There's the Twitchell Reservoir highlighted in yellow. And what I just want you to notice here is kind of the shape of the channel. It makes a nice arc around the city of Santa Maria. And it's mainly doing that because it's got these constraints, these levees. I don't know if my cursor is showing up in the shared screen. Is it? You guys can see it?
Yeah, so we can see it.
Yeah,
great.
I see it.
Thank you. So if it weren't for these levees, this river would kind of meander much more around the valley. And that's what it did historically, well before human beings ever arrived here as well. The reason that this valley exists is because the river historically would have really taken its time flowing out to the ocean. It would have had a really large floodplain. And that's what makes a bunch of great agricultural land here. However, that's not really conducive to having a nice, predictable environment to live in. So levees have been built to keep floodwaters out of these lands. And that's really why the river has this very straight shape, which is a bit unusual for most rivers. And then one of the reasons I highlight Twitchell here is that it's an artificial lake, and it's used to regulate the flow that comes into Santa Maria, the Santa Maria River, to optimize its use for agriculture, and also to help with flood flows. During a really bad storm event, this dam can be used to prevent damage as much as possible. And then just for a little bit of historical context, the Santa Maria River, like I said, used to flood all over this valley. And when it was first settled, it still was like that. There wasn't a cohesive dam or levee system to keep it constrained. And so it would kind of spread out during large storms. And you can see that in 1913, the city was flooded pretty significantly. There's some people there for perspective. In 1952, there was a big one, and there were other large events as well. And so that's kind of been one of the main, most important relationships between the river and people in the Santa Maria River Valley. Is it's been a source of flood, but also a source of water for human uses. And then eventually we decided to build a nice big levee to keep that thing out of the city. And there's a levee trail system as well, which I encourage people to use. And we'll be seeing some more of that in person. And that's just to reiterate the function of Twitchell Reservoir there. It's also, in addition to the levee, Twitchell Reservoir is one of the flood prevention solutions. So I just wanted to review kind of some more recent history. This is the city of Guadalupe in 2022. This is an aerial from Google Earth. And I just want you to notice the width of the channel here. All of this kind of tan stuff where there's not much vegetation, that's, you know, the active river channel. It's dry now in this picture. But then after the storms of 2023, you can see that the sediment got deposited way beyond that narrow section. So this flood caused some real damage in the town of Guadalupe. The levee here coming off of the right side of the screen basically just stops right here. And after that, the river decided to do what it wanted, and it spread onto its kind of historical floodplain. You can see that really in the shape of the margin here around the river. This shape isn't an accident. That's where the river, you know, flowed historically, and the human beings who built this stuff kind of acknowledge that boundary, but you know, sometimes the river wants to take it back. So that's what happened there. A lot of damage, and it's being corrected right now. But some of that damage actually spilled over into the estuary as well. You can see some water standing here. This is after the floods. You're not looking at water, you're looking at sediment that was deposited by the flood. So the water was pretty high here.
I have a question for you, Tim.
Yeah, sure.
Can you go back to the last slide?
Yeah.
See where the levee ends and the water is flowing straight west, and then it looks like there's a berm built up over there. If they hadn't built up that berm, maybe the land is a little bit higher than it needs to be to go straight. But I'm just wondering if the berm wasn't there, if it would have gone straight and not gone as far south and affected the city of Guadalupe as much.
So just to be clear, do you mean like this spot that I'm circling?
Right.
Yeah.
It looks like some of it did flow there.
Yeah, it does look like it got maybe a little bit breached there. And to my knowledge, there are some kind of, you know, community maintained dams, or not dams, levees there.
Yeah.
But they weren't, you know, engineered and built to the same spec as this really robust levee here. And so to my knowledge, there is some stuff there to keep water out. It is hard to say what the water would have done if that levee wasn't there. I'm sure it would have filled this in a little more. But I think also this constriction here might have still caused this to spill out regardless. Like I was highlighting before, this kind of curved area that represents what the floodplain that the river wants to occupy. And so
it seems like, you know, a solution in the future, maybe to get some of those farm fields there so it could spread further north rather than going to Guadalupe. But that's something to be discussed later.
Yeah, that's kind of like a concept that is being used in the Central Valley as well, where there's land that farmers are being paid for to, you know, basically turn it into a floodplain that sinks water into the ground for the groundwater aquifer. And they won't grow crops on it during that time, but they'll get compensated for the use of the land as a way to percolate water. But yeah, the Santa Maria is kind of a different system, so we'll have to see how that plays out.
Right.
And this is a spot further upstream. This is Santa Maria right here on the bottom left corner, and there's the river running along. And here's what happened after these flows. You can see again, the river got pretty wide, deposited a lot of sediment, and some of that will be kind of recolonized by plants, probably like happened here, but it'll take some time. Unless
I'm sorry, some of that will be what?
Some of this, you see this wider area where the sediment was deposited. It kind of got deposited on top of some vegetation that was around here. But over time, that will recolonize with plants. Plants will start growing there again. So yeah, the shape of the channel changes with these kinds of events. And what you can see in this picture is this is actually liquid water here, and then it just dries out right here, right before the 101. I believe this picture was taken in May of 2023. And yet what we know is that this water is actually now flowing past the 101. And that's because of the operation of the Twitchell Dam.
Right.
And this stuff is more accessible to us right now than the estuary. So that's where we're kind of pivoting for this year for water quality monitoring. We're going to try to get a glimpse at what the water quality is like as it passes through this section that's normally dry, except in this case where we have a lot more water than normal. And we're just zooming in here on the top left of this map, zooming in on Fresker Park.
Mm-hmm.
This is going to be our access point for water quality monitoring. So this yellow line is going to basically the path we'll take.
And that's the path that Ken and I took when we went to check it out, but we're actually going to recommend that we go a little farther upstream before we go a little further east. Yeah, that road, that path.
Okay.
Or actually the next one, the next path that kind of goes an angle. Yeah. Because this is where the signage that the city has, and we can go there and then cut across. We don't have to go all the way the direction to where it gets out to the river, but we go maybe a third of that pathway, then we cut over. And it's less walking on sandy riverbed. It's more walking on hard dirt. And so it really takes maybe a little less time. And it also shows what the city has out there.
Yeah, that's great. And yeah, from this image, you can see we're probably going out to where the water was just about drying up in May. But like I said, Twitchell Reservoir is releasing more. And so when we walk out there, there's going to be liquid water flowing through here. And last I checked is about 100 cubic feet per second, which is quite a lot.
Yeah, I wonder how much longer that will last before they've released everything they're going to release.
Yeah, there's there are stream gauges along the Santa Maria River, and the USGS excuse me, USGS reports those flow rates, and so you can actually watch over time. You can check in every few days and see where that's trending up or down. And I think it's going to be trending down. But we are in late September, and depending on how things go, I could see it staying wet for quite a while. And I'm just going to review estuaries here a little bit. Like I said, we're not going to be able to monitor those at this time, but just wanted to review that. So what is an estuary? If you haven't heard of it, it's a partially enclosed coastal body of brackish water, brackish meaning slightly salty, but not as salty as seawater. Partially enclosed coastal body of brackish water with one or more rivers or streams flowing into it, and with a free connection to the open sea. So Morro Bay is like a really classic example we have on the Central Coast that people might be familiar with. It's really popular. And here at the bottom, you can see this free connection to the open sea. Morro Bay has that. It stays open year round, and the tides come in and out, and boats can access it from the ocean. There is kind of a technical difference between an estuary and a lagoon, where a lagoon will seal itself off with a sandbar. And so in the Santa Maria River, we're dealing with a lagoon. It seals itself off. But the kind of common terminology is estuary. And they do have similar functions in terms of habitat, but they do slightly different things.
That's new to me. I didn't realize that about lagoon versus estuary.
Yeah, the term is still used pretty interchangeably, though. And so here's some images from the estuary and aerials around that. Just a little more on like the basic functions of estuaries. It's the final destination of the river's water right before it gets to the ocean. So everything that the water has touched on its journey through the watershed that could be dissolved in the water is going to end up here. And so the Santa Maria River estuary has quite a bit of pollutants in there, because you can imagine every pollutant that's in the watershed that the rain contacts gets swept down to the estuary eventually. So that's why it's also a critical point to monitor and keep a watch on. And it makes it a challenging problem to fix pollution in that estuary, because you're basically battling the whole watershed. But there are ways to do that. And so at the estuary, the river, the ocean, and land uses mix together. That's the gist of what I just said there. So I have an aerial from 1938. These are the dunes just north of the estuary. You can see that dark part here is the estuary, and here are the dunes. This is pre-development. Today, here's a picture looking inland toward Guadalupe. That picture would have been taken as if you were kind of down by this dark part with your back to the ocean looking in. And upstream, just a little bit up from the estuary, you've got some agricultural land use here. And then by 1961, you can see there's quite a different layout of these dunes. They were developed for oil, and to this day, these roads still exist, but there's a lot more remediation going on now. It's not producing oil any longer, but a lot of money is being spent, fixing the damage.
Would you go back? Yeah, 1938. So, okay. I get it. Well, it's a huge difference.
Yeah. So why is there an estuary here? One, the river terminates there. So you're always going to find an estuary wherever there's a big river terminating at a beach. Not 100% true, but generally in California. Critical to the estuary's development is the delivery of sediment in the form of sand, largely from the river. All the sand that gets carried down from the river is an important part of how the estuary functions and how the beach functions. Coastal erosion at beaches is at least partly driven by the rate of sediment that gets delivered to the ocean from a river. And so if you cut off a river's supply of sediment, you can end up with coastal erosion. We're not really going to talk about that, but I thought I'd mention it. So this is not the Santa Maria River. I actually don't recall which one this is, but it's just a really nice example of the forces involved. The river, as you can imagine it having kind of a battle with the ocean. It's always trying to push out, and the ocean is always trying to push in. And eventually they reach a stalemate at these estuaries, and a sandbar will form, and it kind of closes them off from each other. That's a critical phase of the estuary's annual life cycle. So here's a picture of the Santa Maria estuary with its sandbar intact. And so you can see that, there's some water flowing in here. The ocean is lapping up against the sandbar, but they are separate. And so that's where we kind of get this brackish condition that I mentioned earlier. There's going to be fresh water coming in here, but also because of how close it is to the ocean, there's going to be some saltwater content as well. And so we get this unique combination of salt and fresh water, and that creates a unique kind of habitat. So some of the uses that people might get out of the estuary, it's great scenery. I recommend people see it as soon as they can. It's beautiful down there. Recreation, it's a great place to if it wasn't contaminated, it'd be a great place to hang out and swim, but maybe not. Migrating birds use it all the time. You can see a huge variety of birds down there. I've come across some Audubon people doing annual surveys there, and there's a lot to see. But like I said, there's some issues. This estuary has one of the highest levels of legacy DDT pesticide contamination. DDT was used extensively in the Santa Maria River Valley, for agricultural purposes, but also to protect people from mosquitoes and the diseases the mosquitoes carry. So it was applied very heavily, and that DDT is still in the water and sediment in the estuary. There's other things too. You've got herbicides and fungicides and nitrates from fertilizer that run off and eventually, stay put in this estuary. And it's unfortunately known as one of the most polluted water bodies on the Central Coast. That does depend on how you define most polluted, but for those things that I listed, it's up there. Then just a little bit about the estuary dynamics. That sandbar will remain in place until the river gets enough water coming down it to break through the sandbar. And that breaking through is a really critical ecological event. That's what allows fish, steelhead, to come in from the ocean and start swimming up the river to make it up to better habitat up in the mountains. So before that sandbar breaks, before the winter storms come, you can imagine there's fish kind of waiting out here. And when this sandbar breaks, they're going to kind of smell that fresh water and they're going to start trying to run upstream. But it doesn't necessarily open every year at the Santa Maria River. If there's not enough flow, we're in a drought year, we may not even get a big enough storm to break that sandbar. That occasionally happens. Okay, I'll talk about water quality for a little bit.
Looks like you're having a picnic on the river.
Yeah, instead of a picnic, we've got water quality sampling bottles in there. So it's full of stuff we were sending to the lab. This is San Simeon Creek up by the campground there. Just wanted to put this back in there to show where we're going to be doing some monitoring training. When I say water quality, it can mean lots of things. It could be, it's the physical and chemical measurements of the water. It could be about how hot or cold the water is, how fresh or salty it is. We were just talking about brackish, freshwater, salty. How clear or cloudy it is. That's another metric some people use. It's called turbidity. How many nutrients are in the water, and how high or low the oxygen level is in the water. That's also important. And there are many other things that can be measured, but what you measure really depends on what your goal is. In some cases, we're talking about environmental water quality. How good is it for fish or insects or birds? Or it could be about human water quality. Can you drink it? What can you use it for? Can you put it on crops? That kind of thing. And so there's this intersection of why you would care about water quality. We've got community, economy, and ecology concerns with water quality, and there's overlap between all of these. So I've just listed some of those things here. I think you can imagine how fishing, swimming, scenery, and relaxation might coincide with economy. If you've ever driven somewhere to go to the beach and hang out, you probably spent some money buying a sandwich or whatever. And so there's economic components to the quality of these places. And likewise, the better it is for people, the more attractive it is. Generally, we would hope that it also means good ecological quality. And so all these things are related. Just a little kind of diagram here of the food chain in the estuary. We've got algae. It's kind of one of the bases of a pyramid, if you want to imagine it that way, of a food chain. And insects are going to feed on those, and fish are going to eat those insects. And that fish might be eaten by who's this here? Maybe a blue heron or a pelican. You see lots of pelicans out at the Santa Maria estuary, and then fishermen. And yeah, I think that kind of relates to this triangle as well. And so water quality affects how all of these function. And to the best degree possible, we want to make sure they're all kind of working in harmony. So what measurements are we going to be doing at this point? Temperature, dissolved oxygen, and salinity. These are fairly basic, but they're also important, and they're easy to measure. So it's worth measuring these things. there's other things we can measure in the future, but at this point, we're going to start with things that a volunteer can easily take out in the field, take some instruments out there, write some measurements down, and learn about the trends in water quality in these water bodies. But eventually, it'd be great to start sampling some other things that I mentioned. We mentioned DDT and herbicides and fungicide, and there might be other things that are important to the community that we aren't going to measure now, but we will in the future. So the relevance of temperature, it's important for everything, as you can imagine. The cooler the water is, generally, the better. We're not going to be freezing the water here on the Central Coast. What we usually worry about is how hot it gets. If it gets too warm, some of these elements of the food chain can get out of whack. Algae can grow really rapidly, while fish die off, or insects may not be able to cope with certain water temperatures. And so if we can check those water temperatures regularly, we can get an idea of whether the water quality is trending up or down in terms of temperature. Dissolved oxygen is important. It's just like the oxygen you breathe in the air, but it's just dissolved into the water. So if you had gills, you would care about how much oxygen is in the room that you're in. Just like if you were in a confined room on a submarine, you'd want to make sure there was oxygen in there for you to breathe. If that stuff runs out, it's just as fatal for you as it is for fish and other organisms. So oxygen just kind of makes its way into water by diffusing from the atmosphere. Even this water bottle I have, it's not showing up. There we go. Even this water bottle I have, the air in it has some amount of oxygen, and that is dissolving into the water. So this water bottle has dissolved oxygen content. You can increase oxygen by aerating it. We see that in the kind of whitewater rapids on a stream. Those are really like churning, and those are going to have high oxygen levels just because they're aerating so much. They're forcing oxygen into them. You can also get oxygen from photosynthesis in algae. So that's a very important source as well. And at some point, very low levels of dissolved oxygen can kill most organisms. We measure this, excuse me, we measure this in units of milligrams per liter. That's just milligrams of oxygen per liter of water. We can measure that with a probe like I've shown here on the screen. And, depending on your purpose, you might have a different dissolved oxygen goal, but when it comes to steelhead, for example, 5 milligrams per liter is a good threshold. Above 5 milligrams per liter, the fish can kind of breathe freely. Below that, it may be getting stressful. And below about 2 milligrams per liter, things start to become fatal. And we're going to measure salinity. That's literally just how much salt is in the water. And that's just going to tell us, how much the water is like the ocean, or how much it's like the river water. Is it fresher or is it saltier? And that's relevant to dissolved oxygen and temperature, but also just the ecological function of the estuary. Different things happen in the estuary when it's very fresh versus when it's very salty. And just kind of to maybe put brackish in perspective, brackish is, kind of sits in between slightly salty and, fresh river water, and then, very salty and ocean. So freshwater, or salinity, we measure that in parts per thousand, and freshwater tends to be on the very low end, and everything in between is, brackish. It's what we're going to find in the estuary. And then seawater is generally around the world about 35 parts per thousand. It's uncommon for the estuary to be that salty, but it can happen in some of our smaller estuaries. And I think I pretty much reviewed this from what I just said, but we chose these because these 3 measurements are relevant to the organisms in the water. To be honest, the temperature, dissolved oxygen, and salinity of the water aren't probably going to impact too much about what you as a human being think about the water, because you're not going to be drinking this and you're not trying to make it into a hot tub. So we chose these for their relevance to the organisms who have to live out their whole life cycle in this water. And in addition to the things that we're not measuring, pesticides, for example, might affect the quality of that water and break, it could cause a break in that food chain between algae and fish. Insects are a critical part of that food chain, and if there's lots of pesticides in the water, it might be affecting how many insects that estuary can produce and how big of a food pyramid that estuary can support. All right, and then how we're going to measure it. This part's quick. There's two ways generally you can measure water quality. You can take samples with a bottle, send it into a lab. It's kind of what I was doing in that picture with the water cooler. And you can also measure it while you're just standing there at the body of water using a meter. And that's the approach we're going to take. Lab samples are a bit more advanced, but they're also important for water quality monitoring. So what this consists of is having a data sheet, having the instruments that you need to fill out that data sheet, and just sitting down for an hour or two at the water body, putting these probes in the water and recording what you see. At the top here, I just want to point this out. That's called it's like a Van Dorn sampler is the name for it. Basically, it's a tube that you can drop in the water to a certain depth and then snap shut these caps on the end, and you can bring up a sample of water from the bottom of a water body. I don't know if we'll be able to use that in the river tomorrow, but we might be able to give it a try. And so what comes next is the field visit and demonstration. We'll go over the equipment and skills. We'll review some of that stuff in the field. And we're going to get out there on Saturday. And we're going to meet at Presker Park. And I think an email will follow with like the actual coordinates where to go. And so you don't need to bring anything. Everything will be brought by Creeklands. All you need to bring is yourself, and we'll tell you everything you need to know.
And a bottle of water.
Yes, water, sunscreen, those kinds of things.
Yeah.
And depending on the weather, maybe a layer or two. And I think we're meeting at 10 a.m. Is that right?
Yes.
10 a.m. And I had a note here for personal safety. It's going to be pretty simple at the river, but when the slide deck was for estuary stuff, there are some pretty important safety things to observe, but we won't cover that today. Yeah, that's it.
Okay, very good. I think I'll go ahead and stop the recording, and we can talk about anything else we need to talk about. Unless you guys want to keep the recording going. Is there anything else we need to have on the recording?
That seemed good.
Covered it.
Covered it. Nancy we knew she had to leave by 5:10 or 15. So then I just sent her a text saying, you want to meet at our house by 9:40 so we can get up there by 10.